Welcome to the online platform of KTCD College of Arts and Science. I am RESHMISREE, HoD Department of Mathematics. In this video, again, another property of absolute value function triangle inequality has to be proved. Then what is triangle inequality? Before that, we are going to our previous knowledge. What is absolute value function? In the last two classes, we defined about absolute value function, and now again once more we can repeat what is absolute value function. Absolute value function is nothing but the distance or distance function. If x belongs to R, then the absolute value of x denoted by mod x is defined by mod x equal to x if x greater than or equal to 0 and minus x if x less than or equal to 0. So when x will be greater than 0, modulus of x equal to positive x, and if x less than 0, modulus of x equal to minus x. Today we are discussing about one of the most important property of absolute value function, that is the triangle inequality. There is a triangle inequality. Now, what is triangle inequality? For every a, b belongs to R, we have modulus of a plus b less than or equal to modulus of a plus modulus of b. This is true for real numbers as well as complex numbers. So, triangle inequality states that modulus of a plus b, that is less than or equal to modulus of a plus modulus of b. Okay. Here our aim is to prove a less than or equal to mod a, and second aim is to prove minus mod a less than or equal to a for all a belongs to R to complete this proof. So how will you prove a less than or equal to mod a? For this, first we prove that for all a belongs to R, we have a less than or equal to mod a. There are two choices for a. What are the choices? First choice, when a is a positive number. Second choice is that when a is a negative number and equal to 0. So, we are proving a less than or equal to mod a by two choices of a. First choice is a greater than 0 and second choice is a less than or equal to 0. Case 1. When a is greater than 0. That means a is a positive number. Then by definition, we can write a less than or equal to mod a. Since a is a positive number and mod a is also a positive number. Since a is a positive number and mod a is also a positive number, we can write a less than or equal to mod a by the definition of absolute value function or modulus value function. So, when a greater than 0, we have a less than or equal to mod a. Now the case is that when a is less than or equal to 0, what will happen when a is less than or equal to 0? When a is less than 0, a will be a negative number, isn't it? A less than or equal to 0 means a is a negative number. So, a must be less than or equal to 0. Every negative number must be less than or equal to every negative number. Here is 0, Here are negative numbers. Then for a less than or equal to 0, we can write a less than or equal to 0. That will always less than or equal to mod a. How that is less than or equal to mod a? We know that by the definition of modulus value function, modulus of a equal to minus a if a less than 0. Then the answer will be positive. Modulus of minus 10 equal to positive 10. Okay, so when a is less than or equal to 0, then we can write a less than or equal to 0, that is less than or equal to mod a. In both cases, that is when a greater than 0 and when a less than or equal to 0, we have a less than or equal to mod a. Here a less than or equal to mod a. So in both cases, we have a less than or equal to mod a. Similarly, by applying the inequality 1, that is a less than or equal to mod a to minus a, we substitute a equal to minus a in equation 1. Then we get, what will we get? Minus a less than or equal to mod a. Okay. When we multiply minus value on both sides, then the inequality becomes reversed. That is minus minus of a. That will be greater than or equal to minus of mod a. That implies minus mod a less than or equal to a. That is in equation number 2. So we have first equation a less than or equal to mod a. Then the second equation is minus mod a less than or equal to a. From 1 and 2 we get minus mod a less than or equal to a less than or equal to mod a. Similarly, for all b belongs to R, we can apply the inequality equation 3. Then we get minus mod b less than or equal to b, that is less than or equal to mod b. So we are proving that when a is greater than 0, a less than or equal to mod a, and when a is less than or equal to 0, we also have a less than or equal to mod a. To prove the second inequality, that is minus mod a less than or equal to a, we already proved these two equations. To prove the second inequality, minus mod a less than or equal to a, we substitute minus a in equation number 1. We get minus mod a less than or equal to mod a, that is minus mod a less than or equal to a. From the equation 1 and 2, we can write minus mod a less than or equal to a, that is less than or equal to b. Substitute a equal to b in equation 3. We get minus mod b less than or equal to a less than or equal to mod b. Now if a plus b greater than or equal to 0, then we can write modulus of a plus b equal to a plus b by the definition of absolute value function. If a plus b less than or equal to 0, then modulus of a plus b equal to a plus b by the definition of absolute value function. That will be less than or equal to mod a plus mod b, since equation 1 implies that a less than or equal to mod a. By that equation, we can write modulus of a plus b less than or equal to mod a plus mod b. Okay. Also, if a plus b less than or equal less than 0, here we take for equal to 0 also. Now if a plus b less than 0, then modulus of a plus b will be minus of a plus b by the definition of absolute value function. That can be written as minus of a plus minus of b. That will also less than modulus of a plus modulus of b by the result equation 1. Hence we can write for all a b belongs to R, modulus of a plus b will be less than or equal to mod a plus mod b. In other words, we can write modulus of minus of mod a plus mod b, that is less than or equal to a plus b, that is less than or equal to mod a plus mod b. Now using this triangle inequality, we will prove the next question. Modulus of a minus b less than or equal to mod a minus c plus mod c minus b. Here there is a point C lies between a and b such that here is a, here is b, then there exists a point C such that modulus of a minus b less than or equal to mod a minus c plus modulus of c minus b. Now we have modulus of a minus b equal to modulus of a minus c plus c minus b. By triangle inequality we can write modulus of a minus b equal to modulus of a minus c plus modulus of c minus b. That will be less than or equal to modulus of a minus c plus modulus of c minus b. So the triangle inequality is over. Thank you.